Okay, so this problem is really just a solution stoichiometry problem like we learned back in Chem 1, but it's applied to doing titrations, which we talked more extensively about in Chapter 16. So don't let that get you stumped. It really is just a solution stoichiometry problem. And the main thing, though, that you're missing in order to do the calculation is you need to understand the reaction that's occurring. And so let me just write that out. So we have formic acid, which has the formula of HCOOH, okay? And that's your weak acid, and it's reacting with lithium hydroxide. So that's your strong base that's serving as the titrant. And with any acid-base reaction, one of your products is water, so that hydrogen combines with that hydroxide to form a water. And then the salt that's left over would just be the lithium COOH. You could call it lithium formate. All right, but the main thing here is to recognize that you start off with this weak acid, okay, and it is being titrated with this strong base. All right, and from this reaction, it's balanced. If you look at the reaction, it's balanced. So that gives you the stoichiometric ratio. So it's 1:1. You have that 1:1 mole ratio going on here. All right, so it's a solution stoichiometry problem, and you always start these calculations with a number that you're given that's not going to be used as a conversion factor. And usually molarities are used as conversion factors in calculations. So we're going to start with the 50 mils of the formic acid. So I have 50.0 mils of HCOOH, okay? Well, since I'm going to use the molarity later as a conversion factor, I should probably change this volume into liters. Well, I know that there are 1,000 milliliters in 1 liter, so now milliliters will cancel, okay? And so I know that things don't react really on a volume basis, they react on a mole basis. So now I am going to use this molarity as a conversion factor to convert between a volume of my formic acid and a number of moles of formic acid. So the molarity tells me that I have 0.400 moles of HCOOH in every 1 liter. So now my units of liters cancel and I have units of moles of formic acid. Well, to answer the question, to figure out how many milliliters of lithium hydroxide are required, now I have to translate between talking about formic acid into lithium hydroxide. So that's what this mole ratio is for. For every one of these that reacts, I need one of these. So I need 1 mole of lithium hydroxide, LiOH, to react with every 1 mole of HCOOH. So now moles of HCOOH cancel, and I have moles of lithium hydroxide. Okay, I'm going to continue the calculation down here. So right now my units are moles of lithium hydroxide, but I want to know how many milliliters of that lithium hydroxide solution are required. So I can use the molarity of that solution to convert between moles and volume. Okay, the molarity of the lithium hydroxide is 0.150. So what that means is in every 1 liter, I have 0.150 moles of lithium hydroxide. Okay, so now moles of lithium hydroxide cancel, and right now I have liters. Okay, and once again, it's specifically asking for milliliters, how many milliliters. So I can just convert that into milliliters. There are 1,000 milliliters in every liter. Okay, so now I have units of milliliters of lithium hydroxide. So if you punch that into your calculator, what you get is 133 milliliters of this lithium hydroxide solution required to reach the equivalence point. And remember what equivalence point means. That means the point at which this sample acid is completely neutralized. I've just neutralized every one of these formic acid molecules.